Friends, in this video we'll see how to create a fun game, something like Geiger Counter, to play with your friends. So let's begin. So I already created this game. So here, this is a very simple UI. I've created an arc. It shows the place where it should go, and then it will point as we tilt. So we can start the controller using these three dots. And once it starts, go to this virtual sensor. So you should device pose, and over here you can play with the sensor. So if you can hear this sound, tuck tuck tuck, that's basically coming from this game. Okay. And if, say for example, if you tilt it, so see, this rotates, this moves, the needle moves, and also the frequency of the sound changes. So this way we can play with our friends with whom we want to point to a particular person by tilting the phone, and whosoever gets the phone, they have their turn. Okay. So let me just quickly show you the code over here. Code is very much simple for this. So first, there are two classes. One is of course the main activity, and another class I have written for drawing the layout part. So first let me explain you very quickly this, but before that, let me do one thing. This sound what you are getting is from this mp3 file. So I have put a mp3 file in my resource folder in the raw directory, and from there I am fetching it in my code. Okay, first let me pause this, or rather stop it, because it's making too much of noise, and let me now quickly explain you the layout part. Okay, so in layout what we are doing is, in this analog meter view, we are first having the constructor which just constructs a paint, which is an environment variable, and an angle of 0 degree, and then it creates in this on draw method, which is an override. It's being overridden. It's creating a yellow arc of color yellow, what we saw, and a needle of red color. Okay, so let's see how this is being called in our main class, which is the main activity. So we'll come back to this analog meter view class shortly, but in the main activity, in the on create, first we are creating the sensors, which is accelerometer, to get the accelerometer details, and we are creating the media player with this particular file which I just now showed. It's a part of it. It's a, like I have copied it. You can download it from Google or somewhere. You should get some kind of clicking noise mp3 file. Okay, and then if the accelerometer is null, of course we will not proceed. We'll just basically that sensor is not available in your phone, but most of these devices these days have the accelerometer. On resume and on pause are basically when you stop and resume the app. That time it will take us. On resume, basically it will re-register the sensor and start doing it. On pause, it will just stop the sensor and it will stop the sound, which is particularly this particular method. Okay, now after on pause, the on sensor changed. So this is the main method. So where when the sensor is changed, it will just take the data from the type accelerometer sensor, and it will get the x and y value. So basically it's trying to calculate the tilt angle based on the accelerometer. Accelerometer is nothing but it just determines how much of acceleration due to gravity, which is basically 9.81 meter per second square, is being applied on x and y direction. Okay, and then based on that it will calculate the tilt angle, and it will pass on that to meter view. Meter view is basically nothing but an object of class analog meter, which I just now explained below. So where did it go? Yeah, this one, analog meter. Okay, we'll come to that shortly. And in the meter view, it this method we can just ignore anyway, not doing anything. Accuracy change is an override method, so we have to define it. And once we have the meter view object updated, which is before the UI part, it has nothing to do with the sound part. So sound part is taken care in the main class itself, which is basically play based sound on tilt. So sound will play here, and here is basically you using a loop handler, and over here is playing the sound based on the tilt angle. So it's calculating the frequency, like not the frequency but the delay. This parameter defines the delay of how much delay we have to give in the subsequent run of this particular run command over here. So it's calculates the delay. So here the maximum delay is 50 seconds, and it's trying to convert this angle here is in degree, so it converts it into multiply by 10 and then subtract it by 300. So it's basically trying to find if it's closer to 300, then the delay will be high, which is basically if it's slant on the x-axis, and otherwise it will be like it will go to 15 off, so it will may make it as 0 also, and then that in that scenario it will be very quickly. Okay, now coming to the drawing part once again. So in this method over here, meter view, which is a part of this which is an object of type analog meter view. It will call the update angle. Okay, so in this update angle method, so it will just basically update the angle and invalidate. Basically, it will call the on draw command again, and this on draw command, it will first draw the arc of yellow with this particular logic. So basically here is doing nothing but it's just drawing the arc from left 50 to right 50, basically with minus 50, and top is 50, and it's setting the angular starting angle from 180 to minus 180 degrees. So basically it's trying to draw a semicircle. So start angle is 180 and the sweep angle is 180. Okay, and in the needle part, what it's trying to do is it's trying to get the first the center, which is basically width of half of it, and this y will be also center height of 2, but why we are doing minus 100 over here is because the length of the needle is taken as with minus 100, so it's somewhere in the middle of the needle node at the end point of the needle is taking, and then it calculates converts back the angle into radians, because that's what is needed over here to draw in the canvas, and then it calculates the end point, the destination point. This is the starting point and end point of the needle, and then it draws that line from the center x and y, and then uses the paint whatever we have defined over here. The only thing is we change the color to 12. We can change the stroke width and all, that is up to us, but yeah, that's all. So more or less that's what it's doing. So in this method it's trying to draw, and in this method it's trying to make the sound based on the frequency. Okay, perfect. So it started. So I'll bring back my sensor to play a bit in this recording, but otherwise, yeah. So this is our neutral position, kind of. We can play with other, see, the frequency increases. I don't know if it's audible on the video or not, but yeah, it increases quite a good amount. But over here, when we choose, it's basically changing the Z part, right? So we can also play with the X part. Okay, so tilt over here. So I think I can go up to this level. So once so if you have noticed, the tilt changes. And also one more thing, so say for example right now the tilt is around negative, right? So this will red needle will move anti-clockwise. Okay, and if you move of course if you move see, I'm moving the y-axis on the right side, so it's moving on the anti-clockwise. However, if I make it positive, then the needle will move clockwise. Okay, so yeah, see, it's moving clockwise. So that's all I wanted to show you in this quick video. I hope this video is useful to you. If you have any questions or suggestions, then please put in the comment section below. Thank you and have a nice day.